Okay, hello everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and his brother Joel Chaiken. We're here to show you, I hope you give suggestions on how to approach SAT math questions. Here we have a non-calculator section, a question that is what they call free response, so there's no multiple choice here. So Seth, I don't know if you've seen this question before, but can you see how to answer this question in about 3 or 4 seconds or less?
I'd say I could do it. I think I was able to do it in about 10 seconds.
Good. Did you do factor by grouping?
No,
Interesting. You didn't do factor
no,
by
no, no,
grouping.
no, 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 no. What I did was think of factor it. I thought of factoring it by grouping.
Yeah.
And then I realized that I started to factor it by grouping in my mind. I realized that the two factors we needed to try were the factors of 10, 2, and 5. And then I looked at it and then almost gave up hope. And then I said to myself, this is a very 5y problem.
Okay. A lot of fives. Yeah.
See, there's a 5 here.
Right.
No, you can't see it. There's a 5 here.
Yeah.
There's a 2 here, which is, which is 10 divided by 5.
Right.
There's a 10, which is a 2 times 5. So maybe 5 is a root.
Oh, very clever.
And then I put in a 5 and I got 3 5s multiplied minus 5 times 2 5s. So these two cancel. When x equals 5, 5 cubed minus 5 times 5 squared, that's 0.
Yeah, zero.
Because
Right.
this is equal to 5 cubed. And then I saw 2 times 5, 2 times x, 2 times 5 equals 10, which cancels the 10 there. Bingo, 5 is a root.
Wow. That's so. Can you erase that middle big five? Because now we have to do it by grouping.
Okay.
Could you erase that last big five? So
Oh,
most people aren't going to see that. Wow, that's pretty
yeah,
cool.
yeah,
Okay, so now let's do it the more traditional way, which if you don't see the factor by grouping is the way to do this, then it's going to be a problem.
yeah,
So the factor by grouping is generally taught as an option to factor. You generally factor by
yeah,
grouping when you have 4 things going on. So
yeah.
factor by grouping, you do a greatest common factor for those guys, which is x squared. So that's x minus 5. You multiply it out. This is x cubed minus 5x squared. That's good. You factor out a 2, greatest common factor between 2x and minus 10, which is x minus 5.
Oh,
And
really?
then you do this funky
Oh,
thing. Then you do this funky
oh.
thing, which is crazy, where you realize these are the common factors of this whole thing. So then you do greatest common factor again.
No, okay,
X
no, stop,
minus
stop,
Seth.
stop.
Seth, let
You
me finish.
realize that
Seth.
stop.
No,
When you
no,
say
I'm
something
finishing.
times x minus
Seth,
5
Seth.
plus, stop, something times x minus 5 plus something times x minus 5, you know immediately 5 is a root.
Okay, but okay, fine,
Yeah.
fine. That's the way you're doing it. Okay, I'm completing it. I'll go x squared plus 2. Okay, and this equals 0, and then you realize that x equals 5. It doesn't take
It's a
that
root.
much longer for me to do it the way I'm doing it
Yeah.
than for you to. How about you say?
No,
You say
no, no. My
3/4 of a
point is,
second.
as soon as you see x minus 5 times something plus x minus 5 times something else, bingo, x
I
equals
know,
5 is an
I know,
answer.
I know, but it's
Yeah,
more.
so it does, the question does not ask you to factor. And so if you want to learn how to do SAT questions fast, you just see these two common factors
Right.
of two products, and you know immediately that making 5, setting x to 5 zeros it out, you get a root, you're done.
Okay, but you're not forgetting the psychology of it, right?
I know. I'm trying to teach people a better psychology of it.
No, but there's an advantage to just following the normal way and then doing something that's comforting because it
Yeah, you could get comfortable, sure. Yeah, yeah, but
because it keeps you.
this gives you more this is a solution. What you've gotten is a complete factorization.
Yes, but how long
And
did
so
it take?
you could also say the other roots. There are two more roots,
Okay.
plus or minus the square root of plus or minus the square root of 2 times I.
Right. Yeah, those are the complex.
They're two
roots.
imaginary roots.
Okay.
Which,
So my argument though is that it doesn't take more than maybe a second and a half to do it the way I did it compared to the way you did. Really doesn't. Really doesn't. Really
okay.
doesn't, really
well, I think though, I must admire you for noticing and applying this trick of factoring by grouping.
That's right.
Factor this pair of terms, and separately factor this pair of terms.
Well, that's what I thought I asked you at the very beginning. I said, do you know how to factor this by grouping? And you said yes. Well, apparently you didn't know how to factor.
No, I thought factoring by grouping. I didn't realize that. Maybe they teach factoring by grouping
Absolutely.
in school.
Well, how do you think I know it? You think
I
learned this?
that.
You think I learned this when I was in high school? No, I never learned this when I was in high school.
Okay. Well, the trouble with it is that it only works when you're lucky.
Well, yes, of course. That's because they gave you this question was a factor by grouping question. Of course, most polynomials can't be factored by most.
Yeah.
Of course.
Yeah.
This is
when you said factor by grouping, what I thought it was you do x minus r1 times x minus r2 times let's the following: x minus r1 times x minus r2 times x minus r3, and then r1, r2, and r3. The product of them, the three product of these had to equal, the product of these three had to equal minus 10. So one of them, so if it has an integer factor, also there's a fact that if there's going to be a rational root, a real rational root, then there has to be an integer root. So one of these has to be either one of them is a 10 and the others are ones or minus ones, or one is a 2 and the other is a 5. And I fiddle around and get the mess around and try to find it, and that's what I thought by grouping was, where you form these three groups.
Got it.
But I see this is not very workable.
Fine. Yeah.
Because it's a problem.
Okay. Yeah, we know why
it's a problem actually when you see the answer. Yeah. It does not have a factorization like this over the reals.
So forget it. Forget it. No one's going to do it that way. Just
forget
it. Just delete. Delete that. That's
a dead end.
This is the way that when they wrote the question, this was the way they intended people to do it.
Yeah.
Okay? And then you just have to remember how to factor by grouping, and when this is called factor by grouping. And it comes up when you have 4 things, and you can see the pattern that there's this minus 5 here. And you see if you pull a 2 out, you're going to get a minus 5. This is a dead, clear-cut example of what's known in modern-day language as factor by grouping.
Oh, okay.
Okay. And this is how
let me ask you, do they give factor by grouping examples where let's see, let's try to make one up. X cubed plus x, and then 5x squared plus 5.
I guess so. And is each one, can you pull out a GCF of each one?
Yeah,
and
between
then
this and this, between this one and that one, x cubed plus x equals x times x squared plus 1.
Okay.
add 5, x squared plus 5 equals 5 times x squared plus 1.
Right.
And now if you want to make it real, let's see.
Yeah, so it's 5. It's
you
x
simply
plus
make
5. It's x plus 5 times x squared plus 1.
yeah. You so you
Yeah.
make let's change it. Make these negative, and then you'll get x squared equals 1. So x equals plus or minus 1 or roots.
Yeah.
That's another factor by grouping. Okay.
Yeah. But notice that if you change this back, it could have gone both. You could have done it this way too.
Yeah.
You could have actually done this grouping and then this grouping, and you would have gotten the same answer.
Oh yeah! Wow! It's x cubed plus 2x.
Yeah, you see, you could have pulled out an x squared. See that?
Cool.
So it doesn't really matter which way you group it.
Yeah.
Okay.
I see. Yeah.
So that's
wow. So group factor by grouping works in this example 2 ways. You group these 2.
Yeah.
Or that's interesting.
Yeah, it is interesting.
Or you could group these 2. These group them the other way.
Right.
Huh.
Yeah, I know. It's interesting. This gives Seth something to think about today.
Yeah.
Okay. It's okay. Seth's getting a review of 11.
Wait. X squared.
No, you can't do x cubed minus 10. You can't group together. There's no common factor between x cubed and 10, though.
No.
Yeah.
Wait, is there a group between x cubed and minus 2x?
Yeah, x.
X.
And then it's x squared
times
minus 2.
X squared.
Yeah, there is. Yeah.
Plus 2.
Yeah.
And the other one is
negative 5x squared minus 10. You pull out the
minus
5.
5.
Pull out the
Okay.
5.
Yeah. Got it. Yeah.
Okay, so this is really example factor by grouping. It's the only real practical way to do it, unless you're really great with numbers, and Seth noticed there was a 5 thing going on here, and he just spotted the answer.
Yeah.
So that's pretty cool. Okay, everyone.
Okay,
well, have a great day. Hope you got something out of this. Like us, dislike us, give us comments, and email us your SAT math questions.
Yeah, I think a comment on this is that when they give cubic equations on the SAT, there absolutely has to be some sort of pattern.
Exactly. Absolutely.
They wouldn't put on the SAT a cubic equation where there was not some sort of a coincidence or trick for you to discover.
Exactly. They're not going to give you what's known as a general cubic equation.
They would not give you a general cubic equation.
They would not. It has to be a special case.
Yeah. In contrast to quadratic, knowing the quadratic formula, the formula that gives the 2 solutions to every quadratic is part of the SAT curriculum.
Right.
And we saw an SAT problem in which they gave you a quadratic with variable coefficients.
Yeah. Right. You have to know the quadratic formula.
Yeah.
And by the way, there is an equivalent there's the cubic equation, isn't there?
Oh yeah.
The
Cardano's equation.
Long. It's like this.
Oh yeah.
It's not this long, but it's like this long. Okay.
Yeah. It's
look
a
it
real
up.
monster.
It's a real monster.
And then there's also a quartic equation.
Wow. Cool.
Yeah.
However,
a key, one of the first really, really cool results when you major in math is learning the proof that there is no formula for roots of polynomial equations of degree 5 or greater.
Really?
Really?
That is a cool thing. Wow.
Yes,
that
was a major advance in early 19th century mathematics.
So that was in the 1800s. They proved that.
Yeah, early 1800s. It's due to Galois, Galois.
Wow.
So look up his story.
Is there a special case where like the 12th one has an answer or the 10th one has an answer?
No, not general. Yeah, of course. Particular examples of higher order polynomial equations have solutions in terms of radicals. Okay. Simply take like x to the 12th equals 7.
Yeah, right.
The answer to that is one answer. The real answer to that is, the two real answers to that are positive plus or minus the 12th root, the 12th radical 7.
Yeah, right.
You have a formula for that.
Right. Wow, that's really interesting. That's cool in math when you prove something cannot be done. That's really good.
Yeah.
Okay.
It was since the 16th century, the formulas for quartics and cubics were known, and mathematicians tried to find a formula for the 5th degree, and they couldn't.
Interesting. And then somebody comes along and says, "Hey, you just can't prove you can't do it." Wow.
Yeah, can't do it.
Wow.
No.
Cool. Okay, that's really interesting. You always learn. That's good to learn a little bit of math history. That's cool.
Yeah.
Okay, everyone. Well, then send us your SAT math questions at satmathquestionoftheday@gmail.com, and we expect to see you tomorrow. Okay, take care, everyone. Have a good day. Bye.